Hello everyone, welcome you all to Startup Academy, your online gateway to success in ISS exam. Today, since the previous lecture, we have been covering the topic Econometrics, which is of Statistics Paper 3 of descriptive type. And today we will continue with that. We have been covering the topic simultaneous equation model. And till now, we have covered what are simultaneous equation model and what are its reduced form. And in yesterday's class, we figured out what are the 2 SLS and 3 SLS methods to solve the equation. Now, 3 SLS is used when the model is heteroscedastic. But when 3 SLS also fails, then what will we do? We have two more methods: limited information maximum likelihood and full information maximum likelihood. So we will start with that today. Limited information maximum likelihood. Or this is also known as LIML. Limited information maximum likelihood. This is used when 2 SLS, or we can say 3 SLS method fails. Or this is also used we when there are weak instruments in the model. And when there is weak instrument, which means that this LIML has less biased median than 2 SLS. When there is weak instrument in the model, then LIML has less biased median than 2 SLS. Now, what are weak instrument? Weak instruments are weak correlation between instrument instrumental variable and the endogenous variables in the model. So when the instrumental variable and endogenous variable between them, the correlation is weak, then that is known as weak instrument. And hence, this method is used when there is weak instrument in the model and we have LIML has less biased median as compared to 2 SLS. Then we use this method. So now, how is this method used? This method, let us suppose a model, simultaneous equation model, where y1 is equals to alpha naught plus alpha 1 y2 plus alpha 2 y x alpha 2 x1 plus epsilon 1, and y2 is nothing but beta naught plus beta 1 y1 plus beta 2 x2 plus beta 3 x3 plus epsilon 2. These are the two equations of a same model, which is known as a simultaneous equation model. Now, what will we do? We will first convert it into reduced form. So, reduced form, we have taken the similar example as we did yesterday. So, it can be converted into reduced form as it is exactly identified. Both equations are exactly identified. You can solve this in your notebook by your own. We are not doing it again and again. So, reduced form is converted as y1 is equals to gamma naught plus gamma 1 x1 plus gamma 2 x2 plus gamma 3 x3 plus u1, and y2 is equals to eta naught plus eta 1 x1 plus eta 2 x2 plus eta 3 x3 plus u2. Now by solving these two equations by OLS, we will get y1 cap and y2 cap, and we will also get u1 follows, sorry, and we will put this y1 cap y2 cap in the above one, and we will get epsilon 1 follows normal with 0 and sigma 1 as your variance, and epsilon 2 follows normal with 0 and sigma 2. So we don't know what is the number of terms in this model, so we can write it as small n. Okay, so till now I think you know all of this. Now what is the change in this method? The change is that we have to find the PDF of y1 and y2. What is the PDF of y1 and y2? 1 upon 2 pi raised to the power n by 2 modulus of sigma raised to the power half exponential minus half x minus mu dash sigma inverse x minus mu. For a multivariate distribution, our PDF of y1 and y2 is given as this. Now, since here we are doing the PDF of, we are doing it for alpha 1 and alpha 2. So we will write here alpha 1 and alpha 2. And what are the x and x minus mu and x minus mu? We know that the model is y is equals to x alpha plus mu 1. So x minus mu will be nothing but epsilon 1 dash and epsilon 1. This will be our x minus mu. So here also it will be epsilon 1. So what is the value of epsilon 1? It is nothing but y minus x alpha dash sigma inverse y minus x alpha. This will be our formula. Now we will differentiate it first with respect to alpha 1 and then with respect to sigma. First with respect to alpha and then with respect to sigma. So we will get two methods. So this is first we take the log of n. It will be minus n by 2 log 2 pi minus 1 by 2 log sigma and minus 1 by 2 y minus x alpha dash sigma inverse y minus x alpha. Now since this is the procedure of likelihood function, first we have calculated what is the PDF, which is also a PDF, and then it can be written as likelihood as well because we have taken the summation over x. So here, instead of n by 2, we can write 1 by 2. So it becomes n by 2 for log. Now here we will first differentiate this log L with respect to alpha. If we will differentiate it with respect to alpha, these two terms will be equal to 0, and we are left with only that term, and that too we are left with first term will be 0, second term will be also 0, third term will be x dash sigma inverse x alpha minus 2 x dash sigma inverse y. So our alpha cap LIML will be x dash sigma inverse x dash inverse x dash sigma inverse y. This will be our alpha cap LIML. And alpha cap LIML means alpha naught, alpha 1 and alpha 2. This will be alpha cap LIML. Now moving on to the second one. If we differentiate log L with respect to sigma 1 and we will put it equal to 0, then we will get sigma 1 cap LIML. We have got the variance and the estimator from this. And similarly, when we take f beta 1 beta f beta, or we can simply write it as f beta, which in turn gives us L, and which in turn gives us log L. And hence by differentiating with respect to log L with respect to beta and keeping it equal to 0, we will get beta cap LIML, which will be nothing but x dash sigma 2 x dash sigma 2 inverse x inverse x dash sigma 2 inverse y. And when we differentiate this with respect to sigma 2 and we will put it equal to 0, we will get sigma 2 cap LIML. So this was your least limited information maximum likelihood method. Now moving on to the second method, which is full information maximum high likelihood. FIML. Full information maximum likelihood is used when we have all the information about our matrices and we don't have limited access to our matrices or our models. Then we use full information maximum likelihood. Now let us take an example for this as well. Let us take the same example, SEM. So y1 is equals to alpha naught plus alpha 1 y2 plus alpha 2 x1 plus epsilon 1, and y2 is equals to beta naught plus beta 1 y1 plus beta 2 x2 plus beta 3 x3 plus epsilon. These two models we have taken. Now the first step would be, except for error term, take all the other terms on the LHS. So our model becomes y1 minus alpha naught minus alpha 1 y2 minus alpha 2 x1 is equals to epsilon 1, and y2 minus beta naught minus beta 1 y1 minus beta 2 x2 minus beta 3 x3 is equals to epsilon 2. This will become our model. Now we can write this model in the terms of matrices. First matrix is of y1 and y2. So, and second matrix is of x1, x1, x2, x3. And third one is of error. So what are the coefficients of y1 and y2? 1 minus alpha 1, 1 minus beta 1. This is for x1 and this is for x2. And again this is alpha naught minus alpha naught minus alpha 2, 0, 0, minus beta naught 0 minus beta 2 minus beta 3. So this is 2 cross 2, this is 2 cross 1, and this will become 2 cross 1. This is 2 cross 4, this is 4 cross 1, and this will become 2 cross 1, and this is already 2 cross 1. So our matrix is complete by this. Now we can write it as AY plus BX is equals to epsilon. We can write this matrix as this thing, AY plus BX is equals to epsilon. Now we can calculate the variance of epsilon. Variance of epsilon will be nothing. It will be variance of epsilon 1, covariance of epsilon 1, epsilon 2, covariance of epsilon 2, epsilon 1, and variance of epsilon 2. This will be it, and we can write it as sigma. So now we know that our likelihood function can be written as likelihood of alpha, beta, alpha, beta, and sigma can be written as 1 upon 2 pi n by 2 modulus of sigma की power half exponential minus 1 by 2 epsilon dash sigma inverse epsilon. Now epsilon can be taken from your AY plus BX and n. Here, what is the value of n? N is the number of models. So here we have two equations in the model. So we can substitute n here. We can write it as 2 upon 2, which will come 1 only. So taking log of L, which will be minus log 2 pi minus 1 by 2 log of sigma minus 1 by 2. Epsilon dash can be written as AY plus BX dash sigma inverse AY plus BX. Now we have to solve it for three things. One is alpha, one is beta, and the third one is sigma. So firstly we will differentiate this log L with respect to alpha and put it equal to 0. Then we will get alpha cap Fi ml, and alpha cap Fi ml is nothing but alpha naught, alpha 1, alpha 2. Similarly, we will put We will differentiate log L with respect to beta, and we will put it equal to 0. We will get beta cap FIML, which is nothing but beta naught, beta 1, beta 2, beta 3. And the third one, log L with respect to sigma, we will get sigma cap LIM. These are the three conditions. Now these three are closed form of the equation. Since the solution is of closed form. What is closed form? Closed form is when we get exactly the solution and not the when we get the solution exactly by solving the normal equation. If we don't get it, we will solve it by any iterative method or approximation procedure like Newton-Raphson method. We can solve it by that, by imagining or considering something, but here we get the direct value, so it is of the closed form. Hence we can write, let alpha 1, alpha cap is nothing but T1, alpha beta cap is nothing but T2, and sigma cap is nothing but T3. So this completes our procedure of full information maximum likelihood estimation, and this procedure has been asked in the exam. They have not come till now for solving, but they have been asked in exam that what is the procedure about, why is it used, and how is the procedure used. So you can take the similar example. You don't have to solve it thoroughly like I have done on the board. You have to write it like this only. Then your answer will be full. You'll get full marks in the answers. You have to explain at every step that what are we doing and why are we doing this. That's it. That will make your answer precise. So I hope you have been doing the work that we are doing in class, and keep on working hard because we have limited time left. And I am saying this in every class. Please pay attention because time will fly, and you won't be able to catch up really fast. This thing has a very vast syllabus. ISS exam is very vast. So start preparing from now only, and we have to be very quick in our preparation so that we have ample time to revise our syllabus. All the best. Thank you.